about the distributive property. I have two different ways to solve this exact problem. Watch this. The first way is pretty straightforward. We can add what's inside the parentheses first. So we do 4 times 3 plus 2 is 5, and that's equal to 20. But there's another way to do it. If we take 4, we multiply it by 3 plus 2 in parentheses. We can write the same thing as 4 times 3 plus 4 times 2. And remember, PEMDAS automatically gives you parentheses around these. And we can do this problem. It would be 12 plus 8, which is equal to 20. The same exact answer as what we got before. The second method is called the distributive property, and today you'll learn about how it works. The distributive property tells us that if a number is outside a set of parentheses, we multiply it by every single term inside the parentheses, not just one, every last term. The number 3 is outside the parentheses, so it has to multiply by everything inside. We have to multiply 3 by x and 3 by 4. So this would become 3x plus 3 times 4. Now we can simplify that to 3x plus 12. We multiplied 3 by x and then 3 by 4. That's it. That's the distributive property. Ask yourself, what should I multiply 5 by? Do you have the answer? It's everything. We have to multiply 5 times 2y and by 1. 5 times 2y and oh, that was really bad. Plus 5 times 1. 5 times 2y is 10y, and 5 times 1 is 5. Notice that the variable stays attached to the coefficient. We only multiply the numbers. Here's a challenge problem. Sometimes there are more than 2 terms. So here we have 1, 2, 3, 4, 5, 6 terms. Every term in this parentheses will be multiplied by the number 2, and we have to use the distributive property. Now, there are still 2 ways to do this. We can add the like terms inside the parentheses together first, or we can multiply everything out and then add it. Everything would have the same answer. Let's add what's in the parentheses that are like terms together first. So we have 2, let me use a different color. We have 2, 10, and 1. These are all like terms because they have no variable attached. So we can make this 2a plus 2y, and then we have to make sure we carry the 6x over, 6x, and 2 plus 10 plus 1 is 13. So we would add 13. Then we would close the parentheses off, and now we have to use the distributive property to finish. Notice that there are no more like terms in these parentheses, so we can't add anything else together. So now we have 2a plus 4y plus 12x plus 2 times 13 is 26. And that's the answer. What do we do when there's a negative number involved? You can see that the negative 3 is outside the parentheses, so we must distribute the negative 3 to every term in the parentheses. We can write this in parentheses, in more parentheses to make it easier after we distribute. So we have negative 3 times 4x plus negative 3 times 6. Now we just do the multiplication and then add them together if possible. Negative 3 times 4x is negative 12x. And negative 3 times 6 is negative 18. Now this is plus negative 18, which can also just be written as negative 12x minus 18. They're the same thing. And you can't add them together, so that's how you use the distributive property to finish this problem. Today we have learned one of the most useful tools in algebra. Whenever you see a number outside the parentheses, multiply it by every term inside. The idea will appear over and over again when we simplify expressions and solve equations, so it's worth practicing until it feels natural. In our next lesson, we'll combine the distributive property with like terms to simplify even more complicated expressions.